Hello students, in this video we'll discuss about the basics of the error analysis. Suppose you are taking a reading, say it is 2.34, so it may be 3.35 also, it may be 2.36 also. So the last digit, this digit is uncertain, this is uncertain. It means there may be some error in the analysis, in the readings. So this uncertainty in the reading is called the error. So you should know what is the error. Error means it is the uncertainty of measurement in measurement is technically, you can say, is technically called as error. Okay, and it is always represented in percentage. Remember, okay, it is always represented in percentage. Okay, so suppose the true value, the exact value is say 2.34. If you take the mean of all these three, then you will get it's around 2.35. So this reading is more accurate. So accuracy means the closeness of the measurement to the true value. How much your reading is close to the true value, that is known as the accuracy. So accuracy means closeness of measurement to the true value. Okay, to the true value. This is the accuracy. Now, what is the precision? Precision means there is a little difference between the precision and the accuracy. Precision means it is the most accurate, you can say, most accurate. It means actually precision is determined by the least count of the measuring instrument. Okay, means suppose you are measuring this reading by an instrument which can measure up to the second place of the decimal. Suppose the same reading you are taking from any other instrument, like more accurate, you can say. So suppose the reading is coming 0.352. Okay, so this reading is more accurate, so you can say this reading is more precise because its least count is here more, so that's why precision is the determined by the least count of the measuring instrument. Okay, smaller the least count, greater is the precision. Okay, so you can write here the precision means is determined by least count of the measuring instrument. Okay, the smaller the least count, greater is precision. Okay, so here least count, what is the least count? It is the up to the third place. That is the, you can say, in case of 2.352, its least count is 0.001, and the previously it was, in case of 0.35, it was 0.001. Okay, so it is less. So for the least count, the precision is more, so it is more accurate. Okay, so now we'll discuss about the types of the errors. A very interesting error. Okay, error may be of two types. Okay, first is known as the systematic and the second you can say it is the random. Okay, it is the random error. Okay, two types of errors are possible. Systematic errors, those, it is clear from the name, it is those which arises due to in the experiment in the system. Okay, so the error produced in the system is the systematic error. So systematic error, you can say these errors occur constantly in an experiment, repeated under identical conditions. See the example. Suppose you are measuring current in a circuit. So initially, suppose it is not exactly 0. The needle is not exactly 0. It is 1. Okay, it is 2. Suppose needle is here, not here 0. Suppose it is here. So every time you will read the reading, and that reading will be +1 always. +1 unit will get in every reading. Okay, that is sometimes the reading. Suppose the 3 ampere, you will read it 4. Actual, suppose it is 5, you will read the 6. So you will find the same difference every time, same difference. Okay, so it is due to the system. So that's why it is known as the systematic error. Okay, systematic error may be again of three types. First is the instrumental error. Second is the, you can say, the error due to imperfection. And third is known as the gross error. Okay, now you should know the differences between them also. Instrumental errors means it is due to the basic or fundamental shortcoming in the instrument. Okay, already suppose the instrument is defective. So you can say it is the instrumental shortcoming. Okay, and the error due to imperfection means if the setup is not adjusted properly. Okay, suppose connections are not correct, or the leveling of the instrument is not proper, or the environment condition is not correct. Okay, suppose an instrument is required of a particular temperature, you are giving some other temperature. So it is due to the conditions. So you can say it is the improper adjustment okay, of experimental setup. Okay, it is not the defect of the instrument, it is the improper adjustment. It is not adjusted properly. And the gross error, it is due to the carelessness of observer. Okay, means you are not doing this experiment carefully. Okay, you are not taking the correct reading, your eyes are not set, you are not looking the meters carefully, not at a correct angle. So that's why you will get the wrong readings. Okay, so this is the gross error. So systematic error in the system, it is three types. It may be three types. First is the instrumental, that is it may be the shortcomings of the instrument already, which is in the instrument. Second, it is if the instrument is not adjusted properly to take the readings, so error that case. And the gross error, it is due to the carelessness of the observer. Now come to the random error. Random error, actually it is the uncertain. uncertain. You can say it is the unpredictable conditions. Okay, remember it is due to the unpredictable unpredictable conditions. Okay, which is not in your control. It is not in your control. For example, suppose you are doing the Ohm's law. Ohm's law is always this experiment should perform at constant temperature, and you are taking the reading, and due to the flow of the current, suppose wire is heat up, then the resistance of that wire will be increased. Okay, so that time the error is known as the random error. So reasons, see what is the reason. Reason is that first reason you can say the first reason possible, small changes in conditions of experiment, small changes in experiment. And the second possible reason of the random error is that incorrect judgment of the observer. Incorrect judgment. Okay, when you have to take what is the right time, what is the correct condition to take the reading, so that is the another reason. So second is the incorrect judgment of observer in taking readings. Now random error, how can we minimize? Because error is error. You should always minimize it. Try to minimize it. So random errors can be minimized by taking algebraic sum of all the observations. So remember, random error can be minimized by taking algebraic sum of all observation and then its mean value. Okay, so take the average of all the readings. So that is the way to minimize the random error. Now we'll discuss some different types of the errors. That is some technical values you can find in this chapter, useful in the numericals. So you should know what is the mean value. Okay, what is the mean value while taking the readings of from any instrument. Mean value means, suppose the reading of the first observation is A1, reading of the second observation is suppose A2. Suppose you are taking the n readings. So the average of all these values, suppose n is there, this is known as the mean value. Okay, this is the mean value of the observations. Clear? Now absolute value, see what is the absolute error. Absolute error for the first observation. It is the difference, mod of the difference of mean and the first reading. Okay, mod means always positive. Say I am taking the example, suppose the 9.8 is the mean. Suppose AM is the mean. Okay, and your first reading is here, it is suppose 9.7. Okay, 9.7. So it is equal to 9.8 minus 9.7 mod. That is, it is 0.1. This is the first reading. Okay, like this. It may be, suppose in I'm taking the another example. Suppose the A1 is not 9.7. Suppose it is 9.9. So in that case, you will take 9.8 minus 9.9. So it is coming negative now. it is coming negative. So but the answer will be the same, because it is the mod. Mod means always positive. Always positive you have to take. So this is the absolute error. Suppose first reading, for suppose the nth reading, absolute error is equal to mean value minus nth observation reading. So this is the absolute error, and you take the mean absolute error. Mean absolute error means delta AM is equal to delta A1 plus, delta means the difference. Okay, so delta AN upon N. So take the average of all the absolute errors, it will give the mean absolute error. And another type of error, it is the relative, or sometimes it is also known as the fractional error. Mean or the fractional error. So it is always equal to the mean absolute error to the mean value. Okay, this ratio is called the relative or the fractional error. Okay, and the last is the percentage error. It is equal to delta AM upon AM, just multiply the above by 100 only. So this is the percentage error. Okay, you will represent it as in the percentage. So this is the I'm taking the example also. You can take the example. Suppose the acceleration due to gravity is, experimental value is suppose 9.7 and the standard value is 9.8. So 9.8 difference 9.7 upon 9.8, okay, into 100, it is the small g. Okay, so this is in percentage, 0.1 upon 9.8 into 100. So you will get the error in the measurement of the small g. Okay, like this. So this is all about the errors, its formulae. Now in next video we'll discuss about the propagation or the combination of the errors. Thank you.